Hi, hello everyone. My name is Petr Heinz, and I'm here to talk about clean Git history, why you want to have a clean Git history, and if you decide so, how you can really manage that. So just to give you some context, who am I? I'm a lead developer and architect in a Czech e-commerce company called Shopsys. We are making open source e-commerce platform based on Symfony, of course, and built for in-house teams. So you can check us out. Well, basically, Git history is the story of your code. Many of you probably want to keep your code clean. Is that right? Who wants who wants the clean code? Yeah, awesome, all of you. That's great. So, well, you have your code clean. That's great, but you would probably also like to have the story of your code clean as well, because the Git history, all the commits you have in your log, all the merges, etc., are really telling a story about your code, and so that leads us to the whys. Why you want to have that clean? So software changes a lot. Software is basically in constant change. There is nothing stable in a piece of software. And behind every such a change, there is a reason. And that reason might not be so clear to everybody that looks at the end result. So the reasons should be described in the story of your code, especially if you're interested in long-term sustainability of your application, if you're planning to work on this project for years to come with a group of developers that will probably change in the meantime, or if you want to open source your project, because then you will have not only your maintainers, your core team working on that, but also a large community. Maybe you think that you can really do with inline commands. If there is a reason for something, you can just write inline command. If some line of code isn't clear enough on its own, you can maybe just add a comment. Well, inline commands are good for some specific use cases, but they're not really great. Did you, by any chance, seen an inline comment that wasn't really true? That was like true a year ago, but somebody changed the code, but didn't really maintain the comments as well? Yeah, comments are never executed, so they don't work all the time. You don't have tests for your inline comments. Well, maybe. Does anybody have a test for their comments? I thought so. So let me talk a bit about what a commit is, because that's also important. A commit well, that's unfortunate. There is this really nice slide, and I want to show you. Oh, here it is. Yeah, a commit is basically made from 3 parts, and people often tend to just focus on this part, the file changes. File changes in a commit are called a patch. you can see it as a patch, and it's not only all the lines that were removed, all the lines that were added. It's also file permissions. So that's a thing that, for example, surprised me when I've learned about that. So then there are the metadata. The most important, or the most well seen, is the commit message, and that should describe why did you make the change, what really happens there. Maybe you like to just put update this file or a typo or something like that in a commit message because it's quick, it's easy, but that will not help anybody that will stumble upon your commit and be like, what the hell? What did he do? And why? The second thing is the author, is the person who made the commit, obviously. But also, there is this different guy, and that's a committer. And these two can be a different person, because somebody could make the commit and be an author, and then somebody could, for example, on GitHub, he could merge it with the squash and merge. And he would be a committer. You often on GitHub see these two faces next to a commit. That means that the author and the committer are not the same person. Of course, there is some date and a time, and possibly a signature if your commit is verified and signed. And then there is this parent. And a commit can have a single parent or a multiple parents for merge commits, but that's not that important. The important thing is that there is nothing more than these three pieces in a commit. And these three pieces are just taken together, hashed, and that's the thing you see when you look at a commit. So, for example, if I see a terminal here, and I write git show, then this is just a hash of these three parts of this commit. So that means that when anything from these three parts changes, the hash changes as well. And of course, if they are the same, the hash is the same. So let me tell you some general best practices for creating the commits. So in our experience, a good commit should be small, but also complete. It's not really, they go in different directions, these two practices, to be honest. Because when something is really complete, it's probably not that small. But what I mean by small is it should have a single responsibility. You probably know single responsibility principle for code, right? Yeah. And it's basically, it says that a class should really do one thing and one thing only. If you have a class that does two things, maybe it should be two classes. It's the same with commits. If you have a commit when you modify two things, why not do it in two different commits, right? And the complete part, the complete practice, means that you should not do a modification that has no meaning, that has only meaning when it's really completed in full. For example, having a feature and then having tests for the feature. This should be a single commit because the parts have no. They are really important for them to be together. And every commit should be a functional application. You shouldn't really do a commit that breaks something, and then a second commit that fixes it. That's important, for example, for continuous integration, because you can then run tests on every single commit and see that it's fine and okay. There are, of course, some exceptions to this rule. There are exceptions to every rule, really. For example, when you're doing test-driven development, you would like to start with the test that fails on your continuous integration, then make it pass. But there is really no reason to have it in several commits after you make it pass. But there is also an exception when you're doing, for example, a search and replace over all your code base, or such a big changes that are automated. Because then, from our experience, it's much better to have just a commit which says, for example, search and replace of this part to this part, and have that in a single commit, even if it breaks the application, and have it fixed afterwards. The reasoning behind this is just that it's very easy to validate if the commit was made correctly, and it can be redone later. For example, if you merge it and then have some problems, you can really verify the operation. So that's a common exception for the functionality of a commit. And now about commit messages. A commit message should have a really short and clear summary on the first line. That's probably important. It should say why you are doing the change, where you're doing the change, and then you can really describe your reasons on the following lines. Describe the reasons, including some links to external info, to, for example, external issue tracker that describes the bug that you encountered and you are trying to solve. Or, for example, a link to a Stack Overflow answer that you used when you did your commit. Because, let's be honest, we all do that. Just Stack Overflow, copy, paste, fixed. So think of a commit as an atomic piece of change. Not in the physical meaning of atomic, as non-dividable, because you can always divide commits into separate little changes, but atomic in the meaning of not dividable while retaining the meaning you want it to have. So it should be really as small as possible while being complete. That's the important thing. And also know that commits are immutable. You can never truly change a commit. You can only make another one. It's important when you, for example, rebase a branch and see that you really didn't do it properly, and then are scared that all your work has just magically disappeared into the void. Know that the commits are there. You can always take them back. So now let's look at the house. When you want to do some cleaning of the history, how can you do that? So git commit. That's not really that hard, but I want to show you anyways. So first, you need to make your changes, right? So I'm here in an article controller, and I want to create another action to list all my articles, for example. So I will call it list action. Now I will just take my variable articles from my article facade. We'll get all visible articles on current domain. That sounds reasonable. Now let's return a render template. I have prepared it before, so I should just find it. Here, article list. I will pass it an argument containing the list of the articles. Yeah, I should really put there the variable as well. That wouldn't work. Yeah, and we have our action, so let's do a commit. I use the A to avoid doing the git add. So let's do a commit, a new list action for articles. No reason for this, just standing on a stage. Yeah. So that's how you make a commit. What if you find out that your commit is bad, that you've just messed something up, like me a few seconds earlier, when I didn't really do it by our standards, our coding standards. If you haven't spot the problem, maybe our coding standards will. So yeah, let's run them in a container. Shopsys framework. Yeah, just search Shopsys framework. ECS fix. Yeah, this will check the coding standards in our repository and fix all the violations. So yeah, 2 errors. You can see that that I forgot to put the brace on a separate line. So yeah, bad me. How can I fix that? Git commit amend. This git commit amend. This command, what it does is that it can really create another commit in place of the current one. So when I run git commit amend, I can run it with A, so I don't have to add the file to the staging area. When I do this, it will prompt me with the same message I've put there earlier. I can really fix that. I can fix this typo, for example. Yay! I'm a fixer. So now I've recreated the previous commit, and there is really in the log. Crap. One line. In the log, there is no indication that I did the previous command, so I don't have to do like typo, second typo. And that's good for me because I don't really know how to type well, and I've been hiding this from my colleagues for 8 years now, because I know how to git amend. They think I'm clever. So that was the git amend. Here you have the git rebase. So when you want to move your branch, so it looks like it started from another commit, git rebase comes into play, and it basically, if I go back, it basically applies the same patch to another parent. So only this part really changes. It just switches the parent. Of course, it makes another commit, as you can see by the apostrophe here. So to really show you, I can run the git log graph one line all, and we can see here it's visible that my master is not up to date. I have this branch master here, and you can see that my colleagues at the office already merged some fixes of annotations issues. So yeah, there is the origin master, and here is my branch. It almost looks like it's up to date, but it isn't. You can see this really straight line here to master, and this straight line here. So yeah, the origin master is the B here, and my master is the A here. And this is my situation. So what I want to do is, on my branch, I want to call git rebase origin master. And as you can see, it applies the first commit that I made earlier, and the second commit that I've made here on the stage. And now, if I look at the git log, I see that the commits are on the origin master. So yeah, that's great. I've moved them. So this brings me to another command called git rebase interactive, and this is where things get a bit scary. But don't worry, I can really show you. For example, I can rebase this on the same branch, git rebase origin master. I will not move the branch. I just want to see the interactive part. So git rebase interactive or git rebase I. This will prompt me with a list of the commands that will be rebased, and it gives me all these commands that I can do with them. Well, let's ignore this part for a bit. The important thing is that it will go from the top to the bottom, apply all the changes like we saw earlier with the git rebase, but we can tell it to stop, for example, on the first commit and allow me to edit it. So we can see this. Now it told me that it stopped after it applied the prepare for demo, the first commit, and I can now run git commit amend to change it. So I can really modify commits that are not on the top of the git log. So I can go really back into history and modify some commit down in history. So I can now run git commit amend, and I can change anything about that commit. So let me just write here SymfonyLive demo, SymfonyLive Berlin demo. Yeah. So let's take a look at the log. One more time. Oh, I forgot about one thing. I forgot to tell the Rebase Interactive to continue. So it didn't, it stopped. It modified this commit as I've told it to, and now I can tell it to continue with the rebase. And it just will apply the second commit, and now you can see that I successfully rewritten the commit message of the first commit. So yeah, that's Rebase Interactive. It sounded scary, but not so much. But there are different things you can do with that, and when you have a branch that is pretty long, it can get messy. So I would like to see something, really. Let's restart that. I would like to show you these commands that are very important for you. Please remember them.
Sorry, I cannot do anything instead of waiting. Technical problem.
Yeah.
Come back in a moment.
Yeah, so these commands. The pick is the default one. It will just apply the changes like nothing happens, like regular rebase. The rewrite allows you to just rewrite the commit message. It's really nice when you have a typo in your commit message or you want to add some details to it. So we can just write rewrite. It will prompt you with the commit message screen, and you can edit that. You have here a command drop. Maybe you guessed it. It will drop the commit as it will not apply the changes, and it will continue happily with the other commits. Then you have squash or fix up. You probably know squash already. It's a thing to do when you have two commits and want to combine it into just one. The squash and fix up commands are very similar to each other, with the difference that the squash will put all the commit messages next to each other, but the fix-up will just drop the commit messages from all the other commits, and will leave there just the one. And the edit one, that's the thing you saw earlier. It allows you to edit the commit with commit amend. You can of course do some file changes as well. So it could look like this. Here you have pretty long branch, and you want to keep this commit C just as is. You want to change D in some manner. You want to just drop E because E is awful. And then you want to combine F and G together. So the final branch will look like this. It will have the C just with different parent, the change D, and the F and G together as one commit. I will not show you the complicated scenarios because there would be a lot of changes and I might mess them up on stage. That would look awful. Yeah. So a fine thing to do with Git Rebase Interactive is auto-squashing. And First, the Git rebase interactive can get really a bit scary or messy, or you just it's not really comfortable. So when you just want to edit some Git commit in history, it might be better to do it another way, and that's fix up commits and rebase interactive auto squash. Let me show you the Git log. It looks like this, and for example, let's say that I want to add some file to this commit I've made previously. I can do it with the Git rebase interactive, with the edit, as I've shown you, but I want to do it easier, even easier than what you've seen. So I will just create a new file. Hi, Berlin. I will add this file, and I will commit this. But I will commit this not as a usual commit, but as a fix-up commit. I will write a -- fix-up, and here I will use the commit hash from below. This will do just, well, a regular commit, but with a special commit message. I will show you how this looks. It's this fix up exclamation mark that makes it really special and magical. Because now I can run Git rebase interactive, write auto squash, and I forgot to write the branch here. So yeah, Git rebase interactive auto squash to origin master. And as you can see, it looks, well, the same as earlier, but it reordered the commits automatically, so I don't have to do that. And it used a fix-up here, fix-up command. So when this will be applied, it will pick the first commit, fix up the change that I've made right now, and then pick the second commit. So when I just execute this, you can see that I have just the two commits. And if I just use git show of the 713, so I see. Here you can see that the creation of the Hi Berlin file is there as well. So I've really quickly edited a file in a commit in history. So yeah, that's pretty cool. And you can here you can use commit hash, or for example other symbols that are used in Git. So I can use git commit fixup equals #1 to modify a commit one commit back in history, or two commits back in history. So this could be really fast to do when you get the hang of it. So that's the rebase interactive, and maybe, just maybe, you are not using Git in terminal. You are not using the CLI. Do you use GUIs for Git? Yeah, there are some hands. So if you use, for example, Tortoise Git on Windows, it does support all the features I'm talking about here. If you use other GUIs, maybe there are some features, maybe there are not. You should really check the support. Or, of course, you can just open the terminal and do it there, because the terminal is very, very powerful. So how this comes into a general development process? At Shopsys framework, we do it like this. We first create a feature branch. Just check out the master and create a branch. We do the work we want to do. So we just put comments there. We try to keep them small, keep them descriptive, but there might be some mistakes or works in progress, etc. So before we want to push that, we just use Git rebase interactive on master, and we clean our Git history. We do all the stuff I've just learned, I've just taught is the word. And we fix the history and really clean it nicely. Then we will push the feature branch and send it to code review. During the code review, we are creating mostly the fix-up commits, because then the reviewer can review just the fix-up commits and see the changes we want to do to what he already saw. And then, because there is the auto-squash feature, we can just call git rebase auto-squash, and Git will just figure out what we want it to do. So it works mostly automatically. Then we will merge the clean branch without fast forwarding, which will result in a nice clean history where one modification went on after another, somewhere in a single commit, somewhere in several commits, and there are no merge health or like several different branches merged into one and another and stuff like that. It can get really, really messy if you don't care about your history. And then just backtracking some modification that really broke your application could be a living hell. So after all this, you can really nicely see why the changes somebody wanted to do happened. There are no typos. Everything seemed like it was done really, really well on the first try. And that's the story you want to tell about your software, right? So, 4 takeaways from this talk I would like you to leave with. First, clean code should come with clean Git history. Second, a Git commit is an atomic piece of change. It should be the smallest thing you really wanted to do. Inline comments are fine for some use cases, but they come with severe downsides. For example, you cannot do them in JSON. So in your Composer JSON, when you have something really weird, we do have weird things in Composer JSON, so let me show you. Yeah, here. We use this notation to really allow for upgrades, because we commit Composer lock on our projects. So here, this thing isn't there. So is that a mistake? Is that a typo? Should I edit there? Who knows? Well, somebody knows. I can just annotate this, and I can see that I know. Are you pulling my leg? So here is the reason why that changed. I wanted to downgrade this bundle because there were some problems. And when somebody reviews the composed JSON, he can look at this issue that was reported and see if it was fixed already. So yeah, that's kind of nice. And the fourth and the most important one, Git is powerful. Use it. When you try to clean your Git history and really try to modify the things and play with it, you will find out that it's not that hard, and it will be a routine for you, and it will allow you to really tackle some problems with version control that you wouldn't be able to handle otherwise. So yeah, that's it. Thanks for hearing me out. And before you have your questions, let me just tell you that there is a surprise hidden in this room. If you really put your hands under your chair, you might find out that you are the lucky one, the Charlie in the chocolate factory, with a Shops's golden coupon. So there are 5 envelopes hidden under chairs. So maybe the right chair has not an occupant. So you should search it. And we have a booth here. Yeah, good, great. We have a booth here upstairs. So come to us, and there are some prizes. And they are great. So if you have some questions, now it's the right time to ask away. And there is a summary of what you've learned. Also the slides are available here, shopsys.com/u/cleangit. So you didn't have to really take a picture of it. So ask away if you have questions. Yeah?
Hi, great talk. Really enjoyed it. One question about how long am I able to mess up or clean up the history? Is it when I already pushed something on the origin, on the remote? So, and maybe otherwise, do you say I'm only able until I push the first time my feature branch, or is the time frame closed as soon as it got merged into master develop whatever?
I understand the question. There is no real time frame. You can really redo anything in your Git history, but after you push it, then change the history, you will have to use the force push. And there are some downsides to that, either with definitely never force push into master. So when you push something into master, that's it, and you shouldn't really try to fix your history from that point on. But on the feature branches that will get deleted, I would argue that you can force push after that, and it's just fine.
Okay, and you showed your development process, and you talked about the auto squash feature. Does it or is the reviewer firing it? Because I don't know how it shows up in the diff for the reviewer to see your changes if you auto squash before the reviewer gets it.
We after squash before we merge it into master. So the reviewer sees the fix-up commits at the end, and he can see, yes, this should be fixed up into some commit in history, and it's great. And when he says, well, your changes are awesome, you are the best developer in the world, we auto-squash the commits and then force push the feature branch. So yeah, there are no further questions. So thank you all.